Hello friends, welcome to Shiksharthi. In this video, we shall be discussing the sum and the product of the roots of a quadratic equation. So let's start. So if you recall my earlier video on the roots and the nature of the roots, this will be a kind of an extension to that session, in which we are going to focus on delta along with the roots. So we know that for delta greater than 0, these are the 6 cases of roots that we can make, and we are talking about real roots. And at the same time, we are talking about a quadratic equation and expression both, because they are nothing but the sides of the same coin. So we are talking about a quadratic expression ax square plus bx plus c, at the same time a quadratic equation of the form ax square plus bx plus c is equal to 0, where a is a non-zero number value. I mean, it can take any number value except for 0. And then we have assumed here that we can write it in the format a times of x minus alpha into x minus beta is equal to 0. So the point that I need to add here is, if the question tells you that alpha or beta are the roots of a quadratic equation, or there is a concept that tells you that there are 2 roots of a quadratic equation, let's say alpha or beta, in that case, how will a quadratic expression be formed when the roots are given? So these are kind of vice versa. So we are saying that if the roots are given, then the quadratic expression will be written like a times of bracket starts into x minus alpha into x minus beta. And how will the quadratic equation be formed? That will be written as a times of x minus alpha into x minus beta is equal to a 0. This we are talking about if alpha or beta are the roots of a quadratic equation, or if x minus alpha and x minus beta are the factors of a quadratic expression. In that case, the quadratic expression will be written like a times of x minus alpha into x minus beta, and the quadratic equation will be written like a times of x minus alpha into x minus beta is equal to a 0. Taking this forward from here, and now we have introduced 3 terms here. So the 3 terms here are, if I say this equation is equal to a 0, we know this is a quadratic equation. So now the moment we equate it to a 0 is what we had discussed. We talk about the zeros of this quadratic equation, or we say the roots of this quadratic equation, or we say the x-intercepts of this quadratic equation. These are nothing but synonymous terms to each other. Okay, so when delta is greater than 0, we say that the roots are real and unequal, and when delta is equal to a 0, in that case we say that the roots are equal and real. So here are 6 cases that we had made, discussing about the type of roots that you can make, both the roots being negative, one root being negative, the other one is 0. Here both the roots are equal in magnitude but opposite in sign. Here the roots are different. We know that the roots are different, but here not only the magnitudes are different, but the polarity is also different. Here one of the root is having a positive polarity and the other is having a neutral polarity, which is 0. Last case here is both the roots are having unequal magnitude, but their polarity is positive. So let us see, in this case, if S denotes the sum of the roots and P denotes the product of the roots, let us see in this case what will be the polarity of the sum and what will be the polarity of the product of the roots in these 6 cases when both the roots are real but unequal. So when both the roots are negative, the sum will come out to be negative. For example, if you take it as minus 1 and minus 2, in that case the sum comes out to be minus 3, which is negative. This is negative. Okay, what about the product? So minus 1 into minus 2, the product becomes positive. Correct? Now if one of the root is negative and the other is 0, in that case the sum, for example minus 1 and 0, the sum becomes what? Negative. The product becomes a 0. Correct? Now if one root is minus alpha and the other root is plus alpha, is trying to say that minus 1 and plus 1, in that case the sum will be what? 0. What about the product? The product would be negative. right? What about if one root is negative and the other root is positive? Here we do not know. The sum may be negative or the sum may be positive. That is dependent on the measure of the root, the magnitude of the root. Let me take two examples. If one would have been -1 and the other one would have been +2, let's say. So let's say here I could have had as -1 and +1 also, but that is in the example that we had already taken. So if one root is -1 and the other root is +2, in that case the sum becomes positive. But if the root was -2 and +1, in that case the sum becomes negative, is what we are talking about. But in this case the product will always be negative, right? Okay, one root is positive and the other root is 0. In this case the product, the sum will be positive, the product would be a 0. Now the last case is both the roots are positive, so the sum would be positive and so would be their product. Now the next case here, when delta is equal to a 0, we know that both the roots are real and equal, right? So the first case that I am taking here is the case for two negative roots as we had taken here, but here both the roots are equal to each other. So what about their sum? The sum would be negative only. And what about their product? The product would be positive. What about in case if both the roots were a 0, right? So let us first write down the equations of these as well. So if I have to write down the equation of this comes out to be a times of x minus alpha. So x minus or minus alpha, which becomes x plus alpha, into x plus alpha is equal to a 0. This becomes the equation. What will be the equation in this case? This will be a times of x minus 0 into x minus 0, which is just like saying a times of x square. Now in this case, what will be the product? The product would be a 0. And what about the sum? The sum will be a 0 in this case, so which I am writing it with a black marker. Or what I can put it here is, we know that the product is a 0 and the sum. So can we put it anywhere wherein we were getting a product as a 0 and the sum is also a 0? No. So in this case, what you will do is, you will say that the sum and the product, both of them are equal to a 0. This is the mark that I have made. So the sum also is a 0, so is the product. The last case here is, I take both the roots as positive. Let's say plus alpha and plus alpha. In that case, their sum and product both would be positive only. What will be the equation here? The equation here will be a times of x minus alpha into x minus alpha, which is x minus alpha whole square is equal to a 0. So you learnt how to write the equation if the roots are given. Now the next thing that we need to learn here is, what if the sum of the roots is given? If the roots are given, now you can write down the expression, right? If alpha and beta are the roots, what will be the quadratic equation that is formed? The quadratic equation that will be formed would be a times of x minus alpha into x minus beta is equal to 0, and the quadratic expression thereafter becomes a times of x minus alpha into x minus beta. Now we are talking about if the sum is given. So we know that the sum is denoted by s, we have assumed here. Let's say this is alpha plus beta, and we know that this is equal to minus b by a. We have proved it in the earlier videos as well. Okay, now we know the product as well. What is the product? Product is alpha into beta, and this we had derived it as c by a. We had talked about the difference of the roots also. Let's say if d is the difference of the roots, in that case alpha minus beta is what we got. Okay, and this difference we got it as under root of delta upon a, keeping in mind if alpha is greater than beta, in that case this will be positive. If alpha is less than beta, in that case this will be negative. So what is the difference that you are going to get? The difference will be either plus root of delta by a, or it will be minus root delta by a, given that a is a non-zero number value for all these cases. Right? Okay. Now let us talk about if the sum is given. In that case, how can I write the equation? Okay. So what do we do for that? If the sum is given, do we know the roots? Yes, we know the roots alpha and beta. Okay. So how do we do it? What do we do to write down the sum? I mean, any idea about this? Okay, so all you need to understand here is if the sum of the roots is given, you can say that the equation thereafter that would be formed is a times of x square minus sx plus p is equal to a 0. This can be proved also, and this can be proved from my earlier videos wherein we were trying to make it as a perfect square. This can be proved from there. But now if I go the reverse way, and now I know that this is how I write the equation or a quadratic expression in case if s, which is the sum of the roots, which is given, and p, the product of the roots, is given, right? Okay, so now in that case, let me just trace it back. So if I trace it back, can I say this is nothing but a times of x square minus, so minus of minus b by a, so this becomes bx by a plus c by a becomes equal to a 0. So then thereafter we'll be able to say that a by a, and then we take the LCM, this is ax square plus bx plus c is equal to a 0. So a gets cancelled out, and eventually the equation that we get is the equation from where we started. So finally, I'll repeat it for you. If alpha and beta are the roots which is given, can I find out the sum? Yes. Can I find out their difference? Yes. Can I find out their product? Yes. Can I write down the quadratic equation if the roots are given? Yes, I can write it down. There is one way of writing down is, if I know the roots, I can always write it as a times of x minus alpha into x minus beta is equal to a 0, and thereafter I can say that the expression is nothing but a times of x minus alpha into x minus beta. Okay. Next, another way of writing it is, you can always find out the sum, you can find out the product, and then this is the way of writing the equation. Please mind it, you cannot assume the value of a to be equal to a 1. You cannot assume it, because a is any number value except for 0. So you will have to write it like this only, right? Finally, now if we know that there is a method that we had learnt earlier also, and the method is splitting the middle term to write the, or to find out, or to factorize, to find out the roots, or to factorize a quadratic expression. I would say that that method is applicable only in some special cases wherein either you are getting an integer as a factor or a terminating fraction as a factor. In rest of the cases, it becomes very difficult for you to guess, and it is based more on guesswork. So what should we do? We should just use this method of finding out the roots, and once you have found out the roots, then you can always say that the factors are x minus alpha and x minus beta. I repeat, you will just use this method, which is the discriminant method of expressing the roots. To factorize a number, you can use the same, which is x minus alpha into x minus beta into a, or to find out the roots of a number, which is nothing but a times of x minus alpha into x minus beta. All you need to do is, we will just take an example here. If somebody gives me a question like x square minus 5x plus 6 is equal to a 0, and I have to factorize this. So all we need to understand here is, what is the value of a here? 1. What is the value of b here? Minus 5. It will be better you write down the value of minus b as 5. The value of c here is 6. Then find out the value of delta. Delta is b square minus 4ac. So how much is b square here? B square is 25 minus 4ac. So 4 into 6 into 1, which is a 24. So now the first root is minus b minus root delta upon 2a, which is just like saying you already have the value of minus b, which is why we have written it as minus b here. So what is the value of minus b from here? Minus b is 5 minus, how much would be root delta? Root of 1 is 1 only, divided by 2 into 1, which is 2. So from here you get the value as 5 minus 1 is 4, 4 divided by 2 is 2. The other root here is minus b plus root delta upon 2a. This is the other root. So do we know the value of minus b? Yes, which is 5. Do we know the value of root delta, which is 1, divided by 2a, which is 2 into 1. So from here we get it as 3. So you can say that the roots are 2 and 3. What are the factors? The factors will be alpha minus 2 and beta minus 3, which is just like saying one factor is x minus alpha The other factor is x minus beta, and this you have to multiply it with an a. So what is the value of a from here? You substitute the value of a as 1 here. So one factor becomes x minus 2 and the other factor becomes how much? X minus 3. This is what you are supposed to do when you are supposed to factorize or make a square out of this or find out the roots. Just use the discriminant rule. Right? I hope that you were able to learn something from this video, and if you feel that this video is really informative and knowledgeable, please do not forget to like, share and subscribe to our channel. If you have already done so, click on the bell icon and select all so that you get regular updates from us. If you want us to do some videos on specific and difficult topics, put it in the comment section so that we can do it for you. Thank you so much. Until next we meet, goodbye.